Hello, this is Mr. Lloyd, and today we're going to go through a C3 paper. This is the 2013 June C3 paper for AQA. This is in the GCSE specification that's going to be examined in 2017, and then in 2018 there'll be a new specification. So, we're going to start with the questions, and then you can pause the video, and then I'll go through the mark scheme and the examiner's notes, which are always very useful, so you know what kind of mistakes you might make. Okay, so question 1. So, lithium's in group 1 of the periodic table. Lithium reacts with water to produce a gas and an alkaline solution. So there's the picture with lithium, the gas, the water. Name the gas produced. Which ion causes the solution to be alkaline? There's the first two questions. So give them a go, pause the video and get back to me. Right, so the gas produced is hydrogen, and the ion that causes things to be alkaline is the hydroxide ion. So you go, you're allowed to write H2 and H for hydrogen, and hydroxide you're allowed to write OH minus, OH, but not lithium hydroxide, because that's not an ion, that's the name of a compound. Right, the examiner's notes are always very useful, but these questions are quite straightforward, these two, so I don't expect there's much to say about them. 3/4 answered that correctly. The commonest wrong answer was carbon dioxide, because that is usually the answer to a question about a gas, and lithium hydroxide, which is the other product of this reaction, but that's not a gas. Only under half the students identified the hydroxide ion, and it suggested hydrogen, because hydrogen's produced, but that's not the ion that makes things alkaline. So there we go. The hydroxide ion is that's more of a C2 question, but it is relevant to this bit here. Right, question 1b. Potassium is also in group 1 of the periodic table. Potassium reacts with water in a similar way to lithium. Write down 2 differences you would see between the reactions of potassium and lithium with water. So for this, you look on your periodic table, you will see that potassium is lower than lithium on the periodic table. So then you need to know the trend. But as you go down group 1, what happens? That's part of the answer. So have a go. Right, so the mark scheme. You could have written potassium reacts or dissolves faster, more vigorously, quickly, violently, explodes. Ignore reacts more, because that kind of implies more potassium reacts rather than it reacts faster. But this is the thing to do with trends. So as you go down group 1, the elements get more reactive. Okay, so there's more bubbles or fizzes faster. So fizzes, you're allowed to write fizzes more, and more gas. Moves faster on the surface. That's true. It melts and forms a sphere. Produces a lilac or purple flame. So that means, well, when you do the flame tests, you need to know that potassium produces a lilac flame. Sodium would produce a yellow flame. There we go. B. Half the students were awarded both marks, but most scored at least 1. A lack of comparison caused many to lose marks. So that is a good point. So if you're asked to compare 2 things together, you have to say something along the lines of more or less, a word that would compare things. So if you just wrote lithium reacts, or potassium reacts, then you wouldn't get the mark. People said that potassium is more reactive with lithium, but that's not what the question's asking. The question asks what would you see differently when you react potassium with water compared to lithium with water. People repeated because they said it was too quickly and too vigorously. Some people said that lithium produced a purple flame as well. All the group 1 elements produced different flames. They said comparisons of the strength of the alkaline were also seen, but you can't observe those. And people assume that lithium is more reactive. No, it's down the group, more reactive in group 1. Right, question 2. Question 2, going on to the organic bit. Wine contains ethanol, CH3, CH2, OH. Complete the displayed structure of ethanol. Off you go. Right, so the displayed structure of ethanol, it's different to the molecular structure because it has the bond showing. So you should have written something along, well, you should have written this. So that's the beginning, then it's CH2, and then a bond to the O, and a bond to the H. And you're allowed to write OH without the bond in the middle. The examiner's marks, most students, drawing of methanol and inclusion of double bond were the most common wrong answers. It should be quite straightforward to do this because they give you the structure for a start. So all you've got to do is draw that, but with bonds. You've also only got 3 alcohols to remember: ethanol, methanol with 1 carbon, ethanol with 2, propanol with 3. Right, next one. Wine left in a glass for several days turns sour. The sour taste is called by ethanoic acid. Complete the sentences. Ethanoic acid is produced from a reaction between ethanol and. This type of reaction is. Okay, so it's left in the glass. So think about what it's in contact with in the glass, in an open glass. Right, the answers. Oxygen, oxidation. So it reacts with oxygen, and a reaction where something reacts with oxygen is called an oxidation reaction. So there you go, and there's plenty of alternatives. So it's only when you write an element, you're allowed to write the symbol for it. So O2, because that's oxygen goes around in pairs, or O, because that's the symbol for oxygen. Okay, next question. Hang on, let's look at the examiner's notes for that. A third of the students got 2 marks, another third got 1, some thought it was fermentation, some said it was microbes, exothermic and endothermic were frequent answers. Air is not specific enough because you've got to give an element. It doesn't say element specifically, but air is a mixture. So when you do a reaction, you need to be reacting it with a specific element or compound. You can't just say air, mixture. You've got to say which substance in the air is it reacting with. Right, next one. Propyl ethanoate, a fragrance, can be produced by reacting ethanoic acid with alcohol and alcohol. Propyl ethanoate is a member of a series of organic compounds. The members of the series all have the same functional group. So there's propyl ethanoate. Draw a ring around the functional group of this series and the displayed structure. So the functional group is the bit that reacts. You've not seen propyl ethanoate, or it's not on the specification, but there is another substance, so compound, that is in the same group as propyl ethanoate that is in the specification. Right, so the answer is this bit, the carbon to oxygen double bond with the carbon. Okay, what did the examiners say about that? More than half. Okay. Name the series as functional compound with this functional group. Off you go. Right, the answers to this is esters. Do not allow ethers. Ethers are completely different molecules, and most of them did. People found naming the homologous series easier than identifying the functional group. There you go. The alcohol used to make propyl ethanoate has a formula CH2, 3, CH2, CH2, OH. Name this alcohol. It's got 3 carbons in. There's your clue. Off you go. Right, the alcohol is propanol. You're allowed to write propan-1-ol. That's because the OH is on the first carbon in the thing. And propyl alcohol. That was a similar one. It was well answered. Good. Right, on to question 3. Oh, it's the 6 marker. So, a student used this equipment to do a titration. Burette, flask acid, white tile, indicator, sodium hydroxide, pipette, pipette. Describe how a student should use this equipment to find the volume of sodium hydroxide solution that reacts with a known volume of acid. Include measurements. Do not describe how to do calculations. So, this is a 6 mark question. got lots of space. It's not asking you to do any titration calculations, which you can't because you're not given any volumes or concentrations. So off you go. Right, the mark scheme. So this is like a level thing. There's also quality of written communication. So simple description will get you 2 marks max. If to get more than 2 marks, you need to say measurements or adding the alkali to the acid. And then to get 6 marks, you just need to describe how to get an actual result. So here are some points. You put the acid in the conical flask. You put a volume of acid measured using a pipette. Yes, so you need a pipette to measure the volume of acid. You put the indicator in the conical flask. You put the sodium hydroxide in the burette. You can swap the acid and the alkali around. It doesn't really matter. You can talk about any indicator you want. You don't need to talk about this colour change of an indicator. Put the white tile under the flask. The reason you put a white tile under the flask is because you can see the colour change of the indicator more easily. So you have a slow addition, because you don't want to miss the point where it neutralises. You swirl it to make sure it all mixes. Okay, so when you do a titration, when you use phenylphthalein and you've got an alkali, you've got an acid, so it's colourless. When you add the alkali, you might see a pink bit appear, pink blob. That's because the alkali is all concentrated where it landed. When you swirl it around and mix up the alkali, the pink disappears because the alkali is not strong enough to make the pink appear. So when it's neutralised, you get a colour change, and then you take a note of the volume of the sodium hydroxide added. So this point needs to get you more than 2 marks. Okay. What did the examiner say? Holistically, so yeah, it's not just based on how many points you've done. Okay, so it also counts on what level of points you've done. Students were not penalised for minor errors such as incorrect indicator colours. Okay, so the main part is working out the practical, not remembering that phenylphthalein is pink in an alkali and colourless when it's neutral or acidic. 3/4 answered well. Well, titration is a very classic experiment. The most common reason is failing to indicate the final burette reading. So you need to say there's a reading to get more than 2 marks. Read back through your answers for misspellings and inconsistencies, such as filling the burette with alkali and then using it to add to the acid in the flask. Many people use the pipette indiscriminately, using the burette with it. You don't need to use a pipette to fill a burette, it's already got measurements on it. White tile causes confusion. The idea of the white tile is to see the colour change more clearly. Okay, nothing else. There you go. And some writing minutiae about how to use a pipette, which you don't need to do. Right, question 4. Question 4. Campsite has a spring where hard water flows out of limestone rock. A student compared the hardness of spring water with 2 other samples of water. The student measured 20 centimeters cubed of water into a boiling tube. The student then added some soap, shook it for 10 seconds, looked to see if a permanent lather had formed. The student repeated the procedure until a permanent lather formed. The results are in the table. So, number of drops of soap solution needs to form a permanent lather. So the spring water is 13, 11, 6. Tap water is 7, 5, 6. 6. Distilled water is 1, 1, 1. Okay. Calculate the correct mean for the spring water. 2 marks. There you go. Those are your 3 numbers. Off you go. Right. This question is 2 marks because there's a trick in it, which if you've done an ISA, you hopefully know that when you calculate a mean, you have to first, you don't just add up all the results and divide by the number of results. First, you check for anomalies. So the answer is 12 because 6 was an anomaly. Okay? Because it's miles away from the other 3. So if you wrote the answer is 12, 13 plus 11 divided by 2 equals 12, 2 marks. If you wrote the incorrect answer but with the correct working, you get 1 mark. If you wrote 10, which is 13 plus 11 plus 6 divided by 3, then you get 1 mark. Because you've worked out the average correctly, you just haven't taken away the 6. What conclusion could the student make from the results? Use the results table to give a reason for your answer. Off you go. Right, so what conclusion can they make from the results? Spring water is the hardest because it took the most drops of solution. Distilled water is the softest because it took the fewest drops. It must be comparative. So you can't just say spring water is hard. You need to say out of the 3, it is the hardest. And you need to refer to the amount of soap. Let's look at the examiner's marks for these. Almost all students need to calculate a mean, but only a third realise there was an anomalous result. Okay. Make sure you know about the anomalous result checking first. This one. They got the correct conclusion but failed to get full marks. Some compared hardness but neglected to provide the evidence, so they need to talk about the soap. Others point out the evidence without drawing the conclusion. Others made a correct statement about the hardness of one source of water but failed to compare it to others. Some just had a relationship, so didn't talk about the actual water in the practical. Then some talked about permanent and temporary hardness, which isn't what the question is about. Then talked about history of the water samples. So yeah, some people went into too much detail with that. Okay, so the question is just asking which one is the hardest and why. How is the white solid produced in the pan? It's a 3-mark question. Let's explain. So just in case you haven't seen this, this is a document that says AQA GCSE Science Command Words. Okay, so it's very useful to know what you're supposed to do in an exam. So they talk about, there aren't many command words to learn. Calculate, compare, complete, describe, evaluate, explain, state, suggest. Use the information. So explain, they need to make something clear or state reasoning. The answer should never be a simple list of reasons. It must be linked correctly. So something, 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 because something, something, something. Okay, or therefore, due to, since. Okay, something like that. So, going back to the question, why is the white solid produced? Off you go. Right, so the white solid contains calcium hydrogen carbonate. It decomposes on heating to calcium carbonate. That's the white solid. Okay, you get 1 mark for the hydrogen carbonate, 1 mark for the decomposition, 1 mark for the carbonate. What did the examiner say? If you confuse it with scum. So scum is when hard water reacts with soap and makes this precipitate. Okay, it's not to do with when you boil the water and break down the hydrogen carbonate. It's a different thing. 1/4 able to get full 3 marks. So that's the sort of thing you need to remember to get the higher levels. Now, ion exchange has been pretty much every exam since 2012 when the exam started. So here's a simple ion exchange column. Hard water, resin containing sodium ions, soft water. How does it soften water? 3 marks. Off you go. Right, so you've got to say the calcium ions in the water. So ions is underlined. You have to use the word ions. Okay. You're allowed to talk about magnesium ions because they also cause hardness. If you get the charge on the ion wrong, you don't get the mark. They are replaced or exchanged for, so that's the 2nd mark, sodium ions. Okay. If you're a bit unsure, remember it's called an ion exchange column. So you are exchanging 2 ions in the column. It's a pretty straightforward name. Okay. Like the film Snakes on a Plane. It's an ion exchange column. You can't get more plain than that. Let's see what the examiner says. Because hopefully most people know this. Good understanding of ion exchange. Good. Over half got all 3 marks. Some didn't get the relevant species, some filtration. Some believed it was to do with greater reactivity. It's nothing to do with reactivity, ion exchange columns. It's just to do with the fact that it puts sodium in the water, sodium ions in the water and takes calcium and magnesium ions out of the water. An ion exchange column is used for a few weeks. Sodium chloride now needs to be passed to the ion exchange column. Suggest why. Just in case, this is what the exam board thinks suggest should mean. The term is used in questions where students need to apply their knowledge and understanding to a new situation. Often there may be more than one correct answer, as students are expected to base their answers on scientific knowledge and/or principles. Useful words are may, might, could, I think that. And there you go. I'm not going to talk about it, but each of these words comes with a example question. Off you go from there. Right. To replenish the sodium ions in the resin, because if the sodium ions are going into the water, they're coming out of the resin, and the calcium ions are going into the resin. And basically there's lots of ways to say that again. It was quite a hard question to answer, about half getting the mark. It also talks about the chloride ions sterilising it, which I see why, because it's mentioned in the question. Anyway, question 4C, 2 marks. Tap water in the UK is safe to drink because water companies add chlorine to sterilise it. Suggest one argument for and one argument against adding chlorine. So it's 2 marks. So if it's 2 marks and they're suggesting 1 for and 1 against, it's 1 mark per suggestion. So just in case you need a reminder, always look at how many marks the question is. It gives you an idea of what you need to write. This case is really easy because you're given 2 things you need to write and it's 2 marks. So off you go. Right. Arguments for. Why would you want to put chlorine in your water? Prevents disease, kills microbes, and you only need a small amount. Arguments against. Chlorine is poisonous. There's no consumer choice, which means nobody asks you if you want chlorine in your water. They just do it. Most students gain at least 1 mark, usually for killing microorganisms. There's some confusion with fluoridation, which is what people put in the water to help your teeth grow strong, but there's also arguments for and against that as well. Arguments against are more difficult. So I suggest you read up on your arguments against chlorination of water. I think most people know why chlorine is put in water and why before they learn it in school, but no one knows about the disadvantages. Right, on to question 5. Low sodium salts, sodium chloride, potassium chloride, magnesium carbonate. A student tests the low sodium salt for the substance on the label. The same test can be used to identify sodium ions and potassium ions. Describe the test. Give the result of the test for sodium ions and potassium ions. It's a 3-mark question. So looking at the marks again, describe the test. Give the result for sodium ions and potassium ions. 1 mark describing a test. 1 mark for sodium ion results. 1 mark for potassium ion results. So at least you know you don't have to write tons about describing the test. Off you go. Right, 5A part 1. So, placing the sample in a flame, sodium is yellow, potassium is lilac. That's the 2nd mark you get for saying potassium makes the lilac flame. Easy. Some students anticipated 5A part 2, which is, why is it difficult to identify potassium ions and sodium ions are present? We'll get to that. Frequent cause of low marks, incorrect flame colours, so you just need to remember your flame colours, you need to learn them. There's no real link between a flame colour and the element. Okay. Some people go precipitation test. Other people just mixed up their tests. Okay. So why is it difficult to test for potassium ions and sodium ions are present? Because the colours mix. Okay, allow colours mix, the colour of potassium. So what did that? More than half students have no. Yep. Some people talk about position in the periodic table. It's not about reactivity here. How would they suggest the low sodium salt for chloride ions give a result? So it's 3 marks. So 2 marks for the description, 1 mark for the results. Off you go. Right, chloride ion tests, silver nitrate. So you get 1 mark for saying you add nitric acid or acid. You just need to write acidify. But if you wrote an acid other than nitric acid, you wouldn't get the mark. So in some cases, it pays to be simpler. Add silver nitrate, you would get a white precipitate. Okay. Ignore goes cloudy, milky, too vague, and because it would go cloudy if you added, if you had iodide ions, it would just go cloudy in a yellow colour, and if you had bromide ions, it would go cloudy in a cream colour. So too vague. Next one, 5C. To test for magnesium ions, they added some sodium hydroxide solution. A white precipitate is produced. This test also gives white precipitates with aluminium ions and calcium ions. Describe how the student could confirm that low sodium salt contains magnesium ions and not aluminium ions. Off you go. Right, 5C part 1. They can add excess sodium hydroxide, aluminium ions redissolve. So there you go, that's what you need to know about aluminium ions. So the exam marks, examiner's points. A third got all 3 marks on the test. A 10th, you just have the question where you need to know your practicals and you need to know your tests. Okay, you could get asked about any practical in a textbook with a yellow box and word practical around it. Okay, so also look for the specification for the kind of practicals you might be asked about. Failure to mention acidification and selection of an incorrect acid. Hydrochloric acid. You can't use hydrochloric acid because there's chloride ions in it. If you used hydrochloric acid, the silver nitrate would just react with the chloride ions in the hydrochloric acid. It wouldn't prove there's chloride ions in the compound. They said a white solution. White solution is different to a white precipitate. A white precipitate is little bits that are white, and the solution could be clear and white. Half got 1, most got 2. Okay. So remember your test for aluminium ions. Right, question 5C part 2. Doesn't contain calcium ions. How would you prove it doesn't contain calcium ions? Off you go. Right, this one. You would put it in a flame and it doesn't go red. So test for calcium ions is it goes red in a flame. Anything else you'd like to add? Better answered. Usually limestone. Well, there you go. Yes, there are calcium ions in the limestone thing. Right, question 6. Haber process. You're on energetics now. Haber process or equilibrium. Haber process is a classic example that you go to. So read everything about the Haber process. Make sure you know its conditions. Make sure you know why we don't use the optimum conditions that would get the most ammonia. So there's a picture of the Haber process. What raw material is nitrogen obtained from? Off you go. It is, of course, obtained from the air. As you go, when you revise C1, you're doing the composition of the air. You know that it's 79% nitrogen. 2/3 got nitrogen obtained from air. Most include methane, the soil, and ammonia. I think they're thinking about the nitrogen cycle. What is the purpose of pipe X? Go. Well, it's an equilibrium. Recycle unwanted nitrogen, or reuse unwanted nitrogen and hydrogen. Because it's an equilibrium, you will never get 100% of the nitrogen and hydrogen reacting. It will be a waste to just let it out, so you put it back and react it again. And make sure you know which substances are being recycled. Right, balance the chemical equation we go below. There'll always be a balancing question. Off you go. Right, you need a 2 here and a 3 here. There you go. So there's 2 nitrogens, N2. 3 times 2 is 6. 2 times 1 is 2 nitrogens, so that balances. 2 times 3 is 6. Sorted. balanced. So it's 2 marks, 450 degrees. The forward reaction is exothermic. Why is it the optimum temperature? 2 marks. Go. Right. A higher temperature would reduce the yield and a lower temperature would reduce the rate. So you need to, and converse means if you said lower temperature would increase the yield and a higher temperature would increase the rate. So what you need to know is when you do a reaction, there's 2 things you need to think about. How much of the product will you make? So in an equilibrium, how much of the reactions turn to the product and how fast are you going to make it? Now, it says that making ammonia is exothermic, right? Which means you need to reduce the temperature to make more ammonia because Le Chatelier principle says that a system in equilibrium will do the opposite to what you do to it. So if you reduce the temperature, it will go to the exothermic reaction to produce more heat energy to increase the temperature again. So you could reduce the temperature way below 450 degrees and you would make a lot more ammonia. But we don't do that because it would take a lot longer to make a lot more ammonia. Okay, so instead you have 450 degrees to have a high rate and you make a good amount of ammonia. Balancing equation is fine. You can try to memorise the equation because it's an important one. Substitutes lost marks for considering only one of the 2, so make sure you answer all the questions asked of you in the exam. And we said good yield rate, you need to explain why. Right, energy level diagram. How does the energy level diagram show the reaction is exothermic? 1 mark, off you go. Right, because this bit is below this bit, the products are below the reactants. So the energy that goes between them is released as heat. Let's see what the mark scheme says. The energy of the product is greater than the energy of the reactant is greater than the energy of the product. Right. Iron catalyst. Draw the effect of a catalyst. Go. Right. You should draw a hill that's smaller than that hill. And the mark scheme says line starting and finishing at the same levels but with a lower peak. What does that say? 2/3 got that right, a little under half got that right. So a catalyst makes a reaction easier by reducing the activation energy. This hump is the activation energy, okay? So to start the reaction off, you need to put more energy in. It's the reason why things just don't react. It's the reason why when you turn on the Bunsen burner and methane comes out, it doesn't set on fire without you having to light it. Okay, so even though methane and oxygen like to react, you need to light the Bunsen burner by putting energy in to make them react first, to break their bonds. Right, question 7. Propane gas. Energy released from propane is burnt. They put 750 grams of water in the beaker. The initial temperature was 17. They heated it. They measured it again. It was 64. So Q is the energy released. M is the mass of the water. Delta T is the temperature change. So that triangle there is delta, the Greek letter capital delta. And if you see it in science, it means change. And then 4.2 is the specific heat capacity of water, the energy required to raise the temperature of 1 gram of water by 1 degree. So calculate the energy, you're given an equation, you're given the mass of the water, you're given 2 temperatures, go. Right, so you need to get 1 mark, you do 64 minus 17, that's 47 degrees, so that's the difference. You then plug the numbers into the equation. The mass is 750, the change in temperature is 47, the specific heat capacity you're given is 42, and the last mark is for the answer, 148,050 joules. Or you could write kilojoules. As long as you write kilojoules at the end, you're allowed to write that number. Right, 7a part 2. Calculate the energy in kilojoules released when 1 mole of propane burns. They burn 6 grams of propane, and then they give you They give you the relative formula mass of propane, and they give you an answer in case you can answer the last question. It's 2 marks. That's not very much. It's quite a lot of work. So, off you go. Right, so first, it's 1085. Okay? So, this is what you do. You've got 6 grams of propane, right? You need to work out the energy released when a mole of propane burns. You don't know if you have a mole. You've got 6 grams. They tell you the MR of propane. It's 44. So what you have to do is you need to do 6 grams, divide it by 44. Why don't we do it now? Just find the calculator. Is that funny number, right? So that you have 0.136 to 3 moles of propane. Okay, so you've got 148,050 joules when you burn 0.136 moles of propane, but you don't want to know how many joules of energy released when you burn 0.136 moles of propane. You want to know how much energy released when you burn 1 mole of propane. So you do 148,050 divided by 0.136, which gives you that number, and that's in joules. So you get kilojoules, you take that number, and divide by 1,000 to give 1,088. So that's, I got that answer right because I was a bit naughty and I only did the moles to 3 significant figures. So obviously you can put the memory in the calendar, put the number in the memory of the calculator. And suggest 2 things that could do to make the results more accurate. Go. Repeat the experiment and calculate the mean, and use a lid, insulate, stir. So you're losing heat, or not all the heat from burning propane is going to the water. It's going into the glass, it's going into the air around it. So there you go. The student's method did not give accurate results. However, this method is suitable for comparing energy of different fuels to just why. And the answer is they have similar effects. So it's a systematic error. So if you're comparing 2 things, so for example, if you were weighing 2 things and there was a systematic error, so the weight, the balance didn't read 0, it read 5, and you weighed 2 things, one was 50 and one was 55. So the difference between them is 5 grams. If you put it on the balance, it's 55 and 60. The difference between them is still 5 grams. So it doesn't really matter if the error is the same if you're comparing 2 things. But what would people say? Most people found that calculation straightforward because they were given the equation. This was more difficult, only a 5th gained both marks. That's because you still need to remember moles calculations, which is explicitly in C2, but bits from C1 and C2 do come up in C3. Okay, there's bits of C3 like to do with limestone or hard water, which links into the limestone in C1. Okay, so you can't just forget completely your C1 and C2 stuff. Most people didn't say taking a mean, but yeah. Okay, we're getting there. Question 7b is a bond energy calculation. So, propane is burned. They give you a balanced equation. 1 propane molecule reacts with 5 oxygen molecules, makes 3 carbon dioxides and 4 waters. So, carbon to oxygen double bond is 803, and oxygen to nitrogen double bond is 464. They give you the displayed formulae to show you how many of each bond you've got. What do you need to do with this energy? What is the energy released? Off you go. Right, so there you go. Let's see. the energy released is 8,530. How did they get to that answer? Well, there's a carbon to oxygen double bond. It takes 803 kilojoules per mole of energy to either break it, or it releases 803 when it's formed. If you look at carbon dioxide, it's got 2 of those. So for every molecule of carbon dioxide made, you release 1606. Then you look at this big number. You have made 3 molecules of carbon dioxide. So the carbon dioxide released 4,818. Okay. Hydrogen and oxygen, 464. Look at water. There's 2 hydrogen oxygen bonds. 64 times 2. That's 928 per molecule of water. But there's 4 molecules of water. 3712. So the answer is you just add those 2 numbers together, 4818 and 3712, and that gives 8530. Sorted. Was that answered correctly? Okay. Right. Calculate the energy. The energy used for bond breaking reaction is 6,481. Calculate the overall energy change. So you do the energy you need to put in, take away the energy released. So you're allowed, ECF means error carried forward, which means whatever number you got for 7b part 1, if you sub it in for this number and do the right calculation, it'll be right. And the answer is minus, possibly, 2,049. Well, it is minus because it's exothermic, and 6,481, take away that, does give a minus. But they're just looking for the energy released. And that's the end of the questions. Let's see what people said. So most people got that one right. Okay, so yeah. If you don't know, examiner's marks have general comments at the beginning as well. They're very useful examiner's notes. Challenge less capable students, able to do very well. It tells you which questions are answered well. So there we go. Yeah, so there you go for C3. So remember, read the question, know your command words. Think about things from C2 that might come up, so like moles calculations might come up. So yeah, that's just your moles calculations. Balancing equations will probably come up. And yeah, so it's been brilliant. I'll see you soon for another one.